look at what is meant by a one-to-one function. A one-to-one function is a function for which every element, A and B in the domain of F, have different range values. So in this first example, 1 goes to 5, 2 goes to 7, 3 goes to 6, 4 goes to 8. This one is 1 to 1. But on the second example, 2 goes to 7, and 3 also goes to 7. So because each individual domain value, um, in this case, 2 of them go to the same value, they're not unique. So the second one is not one-to-one. So let's determine whether each function is one-to-one. F of x is negative 3x minus 7. We have to show that f of a equals s of b means that a is equal to b. So f of a equals f of b means that negative 3a plus 7 um, is equal to negative 3a, negative 3b plus 7. So negative 3a equals negative 3b implies a equals b. So f of x is negative 3x plus 7 is 1 to 1. Let's decide whether um, this function is 1 to 1. F of x is the square root of 49 minus x squared. Well, let's pick a equals 7 and b equal negative 7. So that a does not equal b. But when I put 7 in, I get 0. And when I put negative 7 in, I also get 0. So this function is not 1 to 1. Now we can also do what's called the horizontal line test. The horizontal line test says that if a function is 1 to 1, then a horizontal line will intersect the graph at most 1 point. So in this case, it passes through 2 points. So graphically, to determine if a function is 1 to 1, we can use the horizontal line test. We see no matter where I put that horizontal line, it's going to cross the function at exactly 1 point. So this graph is 1 to 1. Using the horizontal line test on this parabola, we see that a horizontal line is going to intersect the graph at 2 points. And so this graph is not 1 to 1. So here's a summary. In order to determine whether a function is 1 to 1, you have to show algebraically that f of a equals f of b implies that a equals b. And then in a one-to-one function, every y value has no more than one x value. And to show it's not one-to-one, you can find at least 2 values that produce the same y value. You can sketch and use a horizontal line test. If the function either increases or decreases on its entire domain, then it's going to be 1 to 1. A sketch helps here too. If it has turning points, then it's not going to be 1 to 1. So let's talk about the inverse of a function. F and g are inverses if and only if f of g of x is equal to x and g of f of x is equal to x for every x. The condition that f is 1 to 1 in the definition is essential. Otherwise, you're going to get g is not going to be a function sometimes. So we're going to use the notation f inverse as f to this negative 1, and we're going to read it as f inverse. It is not 1 over f. All right, this is a confusion that when you're first starting can be a bit of a challenge. So make sure you recognize that as inverse, not 1 over f. So let f of x equals 2x plus 5 and g of x is 1/2 x minus 5. Are they inverses? Well, f of x is 2x plus 5 is a linear function. It's 1 to 1, and so it has an inverse. To determine if g is the inverse, you need to find f of g of x and g of f of x. So f of g of x is going to be what? 2 evaluated at 1/2 x minus 5 plus 5, or x minus 5. Next, we need to find g of f of x. So that's what 1/2 times x. In this case, x is f, which is 2x plus 5 minus 5. Simplifying, I get x minus 5/2. These two do not equal x, and therefore these two functions are not inverses of each other. Suppose I want to find the inverse of a list of points. Well, f is 1 to 1 and has an inverse since each x value has a unique y value, and each y value corresponds to only one x value. So to find the inverse, you switch the x and y values. So f inverse instead is going to become negative 8, 2 from the negative 2, 8, negative 1, 1, 0, 0, 1, 1, and 8, 2. Find the inverse of g is negative 2, 5, negative 1, 2, 0, 1, 1, 2, and 2, 5. Now, to start with, do you notice anything about the first and last terms? All right. Um, 5 corresponds to two x values, negative 2 and 2. So g is not 1 to 1 and doesn't have an inverse. Now let's find the inverse of the function h defined by the table, where we're given the years and the number of hurricanes. Each x value in h corresponds to one y value. And however, we see that the y value of 2 corresponds to two x values. So this function is not 1 to 1, and so it doesn't have an inverse. Now, to find the equation of the inverse, you switch x and y, you solve for y, and then replace y with f inverse. So is f of x equal to x a one-to-one function? And if so, find the equation of its inverse. Now, it turns out that this is not one-to-one. So f of x is equal to the absolute value of x. It's not one-to-one, and it does not have an inverse. Is g of x equal to 4x minus 7 1-to-1? And the answer is yes, it passes the horizontal line test. So to find the inverse, you switch x and y and solve for y. And then the last step is to replace y with the inverse, g inverse of x. Is h of x equal to x cubed plus 5 1-to-1? And the answer is yes, it passes the horizontal line test. To find the inverse, you switch x and y, solve for y, and replace with h inverse. The rational function f of x is negative 3x plus 1 divided by x minus 5 is 1 to 1. Let's find its inverse. So you replace x with y, you switch them, and now we're going to solve. So you clear your fractions, you distribute, and you want to get all your y terms on one side, all your x terms on the other, factor a y out, and divide. So f inverse is 5x plus 1 divided by x plus 3. Let's look at a graph. Are these two functions inverses of each other? Well, we can see that they're not inverses because they're not reflections across a line y equals x. Let f of x equal x squared plus 4 for x less than or equal to 0. Now we've restricted the domain. Find f inverse. Now, because the domain is restricted, the function is one-to-one, and so it does have an inverse. So to find the inverse, we're going to switch x and y and solve. The domain of f is the range of f inverse. So f inverse is negative square root of 4, square root of x minus 4. Now we need the negative root instead of the positive root because we restricted x to be negative, and therefore y has to be negative on the inverse side. Now, if I were to graph f and f inverse and the line y equals x, if I were to fold these graphs along this line y equals x, they would match up perfectly. Important facts about inverses. If f is one-to-one, the inverse exists. That doesn't mean you can find it nicely. The domain of f is the range of f inverse. The range of f is the domain of f inverse. The domains and ranges switch. If AB is on the function, BA is on the inverse. The graphs of f and f inverses are reflections across a line y equals x. And to find f inverse, replace f of x with y, swap x and y, and solve. Now these are just kind of fun. Suppose I have a function defined by a message defined by the function f of x is 3x minus 1. And we encoded a message 11, 44, 74, 44, 42, 59, 68, 14, 14, 59. And we say you need to find the inverse function and decode the message using the values given. Now we can see the values given. A is 1, B is 2, on down to Z is 26. The first thing we need to do is find the inverse. So you switch x and y and solve for y. So y is 1/3 x plus 1/3. So that's my inverse. So to decode the message, we're going to put in the values. F inverse of 11 is 4, and 4 corresponds to D, A, B, C, D. 44 is, F inverse of 44 is 15, and that corresponds to O. 74 corresponds to 25, which is Y. 62 corresponds to U. 59 corresponds to T. 68 corresponds to W. And 14 corresponds to 5. So you can kind of create your own messages with this.